Hello, and we are back with another laptop repair today. So this is an HP motherboard. So we got this motherboard from another repair shop. So the problem with this motherboard, it doesn't turn on. So it's a no power case. So we can see its model number here. The part number is LA-B972P. So we have a nice motherboard here. So let us first physically inspect if there is any problem, any corrosions or any burn marks on the motherboard. Let's have a look at it. So already someone has tried to repair this one. Let's see whether we can fix this one. Okay, let's have a look at it. No problem in these areas. The board looks fine here also. So this is sound IC, so it's no problem. Looks fine. On the other side, so here we have the DC in jacks and also the standby sections, the inrush limiters here, which switches on and off the DC 19 volt back to the board. The EC chip here, there's no problem in the EC chip. Looks fine. RAM slot also looks fine. Okay, these two are probably the 5 volt and 3 volt power supply for most of the regulators on the motherboard. So these we call as standby sections or the standby voltages. So MOSFET. Okay, now let me remove the heatsink and look under the heatsink whether these MOSFETs are fine. Okay, there you have here we have a burn mark. So most probably there was a MOSFET here and the MOSFET was burned, and I think they have taken out the MOSFET, the burn MOSFET, but they didn't fix it. So actually the MOSFET that is shorted is the upper MOSFET. Yes, so upper MOSFET means it is directly connected to the 19 volt. So here we have an inductor, so most probably this is directly connected to the 19 volt and it comes to this point here and it will go into this point as a 19 volt input for this section, for this regulator section. And in order to place another MOSFET in this place, we need to find out the gate pin and also the source pin and also the ground, the drain pin. Okay, so I think it is visible here. So it looks like this is the gate pin of the MOSFET. So this looks like the gate pin of the MOSFET in this side, and here we have the source pin and also the drain pin. So I think we can place another MOSFET here, but anyhow, before placing another MOSFET, we'll have a diode check everywhere in the coils and come back and place the MOSFET and see whether we are getting the voltages. So this is most probably this is 5 volt and 3 volt line. So I guess this should be 5 volt line, this area, but I don't know. Anyway, we will try. Now let's go for a diode check. So we usually start from the current sense resistor to check the upper MOSFETs. Okay, so in order to check each of the coils in this motherboard, so in order to check the upper MOSFET, we can start from a common point. So here we have an electrolytic capacitor which filters the 19 volt. So I will keep one of the probe, which is the negative probe, on this positive connector here, positive side, and check each of the inductors. So the value should be around 400 or higher than 400. So 530 it's fine. So it's CPU coil, and here we have 3 volt coil. Okay, 560 at this point, 540. Okay, so the upper MOSFETs are okay. Now we can check with regard to ground. So we can swap the probes and check each of the inductors. So 540, okay, 83 fine. On this side 485. On this side, ooh, it's 0.003, which means the lower MOSFET is shorted to ground. Okay, fine. Okay, now let me remove the lower MOSFET and check again, or else I can lift the coils here, the inductor in this place. I can lift the inductor in this place and check whether on which side it is having the 0 ohms. So it's reading 000, which means it is shorted to ground. So I should get 0 ohms on the regulator side, not on the output side. If we are having short on the output side, then we have to trace whichever the places goes into the motherboard, these lines, we have to trace and find the fault. Okay, now let me lift one of the side of this coil and check it. So you can see now I have lifted the coil, so it's not in its place, so it's above its place. Okay, we are reading 480 on the output side, so only the MOSFET is faulty. So if you change the MOSFET, everything will be okay, or else the standby section, the standby regulator IC is the faulty. So either the MOSFET or the standby regulator is the faulty. So other than that, there is no short on the output side, so it's a good symptom. So usually we will be having the short on the output side, but on this motherboard we are lucky that we are having only the short on the regulator side. Okay, now let me remove the MOSFET here so that we can check it. Okay, let me check this MOSFET whether it is fine. Okay, this is an N-channel MOSFET, so we should keep our negative probe on the drain side, which is on this side, and on the other side we can keep the positive probe, and we should get around 400, but it is reading 0, which means the drain and source is directly connected, so it is not acting as a MOSFET. On the other side, oops, yes, Even if I swap the probes, it is reading the same. Okay, so we need to change this MOSFET. Okay, before changing the MOSFET, we need to find a solution for this MOSFET, for the upper MOSFET. So there is no pads for the upper MOSFET, so we need to find a small pad for the drain point here, this area. So we need to build a pad. So just a little amount is enough, just to protect the pad under this. Okay, now it looks fine. We can cover everything. We can scratch the excess amount of UV after curing it. Okay, that looks fine. The UV will be cured just in 25 seconds, like 5 or 20 seconds. Let me check it now. Yeah, now it's okay. It's fine. Okay, now let me scrape a little bit in order to expose the pads. Okay, it looks clean. Now let me place a new MOSFET on that area and try to fix on the place. First I can thin the pads before placing the MOSFET. Now I will apply some paste solder here and here also, just to give a good grip for the pads and the MOSFETs, better than the solder wire. Oops, flee away. Okay, the MOSFET is well fixed in its place. So you can see on this pad here small bolts. This is the source pin, the gate pin of this MOSFET, and we have the source pin connected to this inductor. So you can see there's no enough connection for the gate pin and also the source pin because the pads underneath has been burnt. So anyhow we had to just to try with the solder in order to connect the gate with this pad below this and also the source with the inductor here. So the drain point also we need to apply some extra solders in order to give a good connection for this site. Okay, now the connection is solid. Let's see on the other side. You can see the gate pin is pointing outwards. Okay, now it's fine. Okay. Yes, we do have 460 reading diode value. So the MOSFET is connected. And also we need to check the gate pin whether it is connected to the standby IC here. Yes, it's connected. So I'll just give a clean over the area. So before that I can place the other MOSFET also. Okay, it is well fixed in its place. I'll just remove the inductor now so that I can chin the both MOSFETs clearly and properly. Okay, now it's visible now, both MOSFETs. You need to make sure that the source and gate pin of the MOSFET should not be shorted together. Okay, so they are not shorted. Okay, so it looks like a reliable connection with the board. Now I will just give a clean. So this work looks like ugly, but anyway, we need only a reliable connection with the board. So we can't expect a quality work in this case here. So, and also you can see there are two capacitors that is missing. So we need to place it here. So for the filtration purpose for the 19 volt going into this upper MOSFET, so we need to place a new capacitor in this place. Okay, now it looks nice, so we can place a new capacitor on that place. Okay, everything is fine. Finally, I will just chin the drain point of the upper MOSFET here, just to get a good connection for the MOSFET. Okay. So finally I will place the inductor. Okay, so before placing the inductor in this place, I'll just give the power, and we need to check whether we are getting 5 volt or 3 volt on this side. But just to check whether our work is proper. Sometimes if the MOSFET is again shorted, it will send the 19 volt back to this coil here. It will go output and it will go everywhere in the motherboard. So in order to protect the other side of the board, so we will just give power without the inductor, so that we can check at this point whether we are getting just 5 volt, and we can confirm that our work is proper. Okay. Okay, now it looks clean. Let me check once again for the last time whether the upper MOSFET is well connected to the board. So here we have the inductor here, which is connected to 19 volt. So I can check from there to this point here whether it is connected. Yes, it's connected. It's showing 523. So we have a connection from the source point here back to the MOSFET here. Okay, and also the drain point, I mean the lower MOSFET of this section is showing 441. Okay, that is also okay. So now I'm going to give power to the board and check everything is okay, whether we are getting a voltage in this place lesser than 19 volt. Then only we can place the inductor in this place. The adapter is connected. Oh, it's taking 200 milliamps. It should not take 200 milliamps. Okay, let me check again. Is anything shorted? No, it's not shorted. Yes, it's increasing. There's no problem. So why there is no light on the charger, and also ampere took around 200 and it dropped to 0. However, everything is fine. Okay, let me check whether the main power rail is present. You can check at this point here. Yes, we are having 19.46 volt. Okay. So what about the LDO voltages? No, we are not getting LDO voltages. No LDO voltages. Okay. So we have to check whether we are having supply voltage for the standby IC here. Yes, 19.46 volt. If I touch this point, still we are not getting any voltage. No LDO voltages. Oh, we are getting 5 volt, I think. It's 4.4 volt. Okay. But no output. No 3 volt LDO. So 3 volt LDO is important for the EC chip to function. Then only we can see the light on this charger here. So we need to find the solution to get the LDO voltage. Okay, let me connect the adapter again and explain you. So you see the ampere is taking around 200 milliamps. So this abnormal ampere is because of the standby IC. So the standby IC is getting too hot. So if I touch, it is getting too hot and it's burning my finger. So maybe the standby IC becomes shorted. So let me check with the ohms value for at the input side of the standby IC in order to see whether it is shorted or not. No, it's not shorted on the input side. We are getting kilo ohms, mega ohms. Okay, over limit. Okay, let me check the gate pins of each MOSFETs in order to make sure they are okay. So this is one of the MOSFET. Okay. On this side here, it is also okay. Here we have one, which is the line we repaired right now. So it's reading 900. Okay. On this side here, this is the upper MOSFET. That is also okay. So there's no problem. Anyhow, I'll try to replace the standby IC and see if we have solved the problem. Because we are not getting even the LDO voltage output. We were getting something around 4.4 volts somewhere here. So I have another standby IC in a spare motherboard, so I can replace it and check it whether we are getting at least the LDO voltage. And also we can check the LDO output side of the standby IC. We can check these two capacitors. These are the capacitors that filters the LDO voltages, 3 volt and 5 volt. So let me check on that side. So we are reading 900, okay, and 743. So that value looks fine. So there's no problem on the outside of the standby IC and also on the MOSFETs here, and the gate pins are okay. So maybe internally the standby IC got faulty. So due to these two MOSFETs were shorted. Okay, so now we can replace the standby IC and see. So we will follow a trial and error method. And let's see whether after replacing the standby IC, we are getting the LDO voltages at least. Okay, now let me try to connect the adapter again. First of all, I'll just check whether there's no short in the input side of the standby IC. There's no short, okay. There's no short. It's reading 500. What about the LDO lines? LDO line is also not shorted. Okay, no problem. Let me connect the adapter again. Yes, now we are getting 10 milliamps. So this is perfect. So the problem is only with the standby IC there. So let us check the voltages, the LDO voltages on pin number 14 and 15. So here we have 1, so we are getting 5 volt. You can see we are getting 5 volt, okay. And on pin number this side we are getting 3 volt. So perfect. So this standby IC is okay. Now we'll check this output here. There's no output, okay. Here also we are not getting output. So in this motherboard, so in order for this coil voltage to be generated, we need to press the power button. So that's why we are not getting any voltages right now. So if you look here, you can see now the light is glowing. So 3.3 volt LDO voltage is now supplying this EC chip. So that's why it is generating the signal here that the adapter is plugged in. Okay, everything looks fine. Now let me plug in the adapter now and try to power on and see whether the board is turning on. Okay, so let me connect the adapter now. So if the board turns on, you can see the change in the ampere on the power supply. So let's see. Yes, it's taking 10 milliamps. So we will try to trigger the board. On pin number 2, yes, the board has turned on. Okay, and wait a minute, I have not connected the heatsink here. So first of all, I will connect it. So the board has turned on. So we should get the 5 volt and 3 volt standby, then only the board will turn on. So we can confirm that the 5 volt and 3 volt is now executing. Let me trigger the board again. Pin number 2 here. Yes, the board has turned on. By the way, we can check all the voltages now. The RAM voltage, CPU voltage, the standby voltages, everything. Yes, we are getting 1.3 volt. It is present. Yes, we are getting 1.7 volt, the CPU voltage. We are getting 3.3 volt, okay, standby voltage, and also 5 volt. So our work is reliable and we are getting the 3.3 volt. So there's no problem. So if you check the voltage at the RAM slot here, we are getting 1.3 volt, which means, so we need to connect only DDR3 LRAM. So let me take a DDR3 LRAM. Yes, it's DDR3 LRAM. Okay. Now, earlier we saw the ampere reading is about 200 milliamps. So after connecting the RAM, we should get above 200 milliamps in order for the CPU to generate the display. Yes, it has turned on. Now you can see it's taking 300 milliamps. So after connecting the RAM, so we are getting 300 milliamps. So therefore the RAM is now detected by the motherboard and it's now communicating with the CPU. Let me connect a mouse here so that we can check whether the display is executed. Still there's no display output. Let me swap the RAM module here, trigger it again. Yes, it has turned on. Still no display. No display. Are we getting all voltages? Yes, the RAM volt is present. RAM voltage is present and also the CPU voltage is also present. 3 volt, 5, okay, everything is fine. So what about this one here? Yes, 1 volt present. This one here, 1.5 volt present. So everything is okay. So why we are not getting a display? Okay, before moving on to checking with the oscilloscope, let me try to replace a RAM module here with DDR3 RAM which works with 1.5 volt. So here we have DDR3 LRAM, so which works with 1.35 volt because the regulator here it is generating 1.35 volt which is suitable for DDR3 LRAM. Anyway, out of curiosity, I will try to replace a DDR3 LRAM and see whether we are getting any change in the ampere reading. Let's see. Yes, we are getting around 400 milliamps. So it is little higher than earlier that we were checking with DDR3 LRAM. Okay. So now let me try to connect a keyboard and see. Yes, we got the display. You see, we got the display. The number lock is responding. So actually, this board is generating 1.35 volt, which is suitable for DDR3 LRAM. But why this RAM is not working? Yes, it's DDR3 PC3 LRAM. There's no problem. So actually it is strange. Okay, anyway, on boards that will work only with DDR3 LRAM, so we will have a notification in this area as written DDR3 LRAM only, but in this motherboard there's no any notifications about that, so we can use only the DDR3 RAM which works with 1.5 volt. So right, anyway, we have solved this problem. So we had a problem in the standby section here. The MOSFET is burnt and we have tried to replace the MOSFET and also the standby IC here. So that's all for today. So we have successfully repaired this one. So thanks for watching. Stay tuned for future updates and bye for now.